Welcome to Numbers Simplified. In this channel, we seek to simplify and solve numerical problems. Today, we'll be looking at the introduction of integration, part 1. Make sure you like, share, and subscribe so that you don't miss out on any of our videos. Now, diving into integration. Integration can be viewed as a reverse of differentiation, dy dx. Recall from y is equals to x to the power n. If we differentiated that dy dx, we would get n times x to the power n minus 1. Then, in order to reverse the differentiation, we need to add 1 to the power, or the index, and afterwards divide by the result of adding 1. That is, we have this y is equals to n times x to the power n minus 1. We add 1 to the power, we divide the resulting power, which is n minus 1 plus 1. Now, simplifying that, we would get n times x to the power n all over n. And as you can see, the n's will cancel out so that we just have x to the power n. Right, with that in mind, we can now come up with the rule for integrating powers for n not equal to minus 1. So the rule for integrating such powers follows. If we have dy dx is equals to x to the power n, then the integration of dy dx is equals to y is equals to x to the power n plus 1 divided by n plus 1 plus c. Now, the symbol is the integration symbol. Dx implies that we are integrating with respect to x. C is the constant of integration, and we always place it, especially when we're dealing with indefinite integrals. Therefore, the integral of f of x dx is an indefinite integral of f of x with respect to x. Now, let's look at an example. Find y in terms of x if dy dx is x to the power 10, b, 1 over x to the power 6. The solution. Recall, we add 1 to the power and divide by the new power. That is to say, y is equals to the integration of x to the power n with respect to x is going to be x to the power 10 plus 1. We divide by the whole new power 10 plus 1 plus the c, the constant of integration. Now, simplifying that, we get y is equals to x to the power 11 divided by 11 plus c. Now, recall from the laws of indices for b, if we have 1 over x to the power 6, that is the same as x to the power minus 6. Then, we continue with our integration so that we have y is equals to integration of 1 over x to the power 6 is the same as integration of x to the power minus 6 with respect to x. We have x to the power minus 6 plus 1, and we divide by the new power, which is minus 6 plus 1 plus the constant of integration. Simplifying that, we get x to the power minus 5 all over minus 5 plus c. Simplifying that further, we can have it as y is equals to minus 1 over 5x to the power 5 plus c, the constant of integration. We are just applying the laws of indices and expressing our answer in a form that is easy to interpret. Now, let's move to the second rule. The second rule concerns integrating a constant, k, which is an element of real numbers. So we are talking about any number. So if we have dy dx is equal to k, and recall from the laws of indices, x to the power 0 is as good as 1, then it implies that y is equal to the integration or integral of k with respect to x is equal to the integration of k times 1 with respect to x. That will give us integral of k times x to the power 0 dx. Adding 1 and dividing by the new result in the power, that will give us y is equals to kx plus c. So that is how we deal with the constant. So every time we have a constant and we are integrating a constant, we are going to have x plus the c, the constant of integration. Now, in summary, the integral of k with respect to x is kx plus c. With that in mind, let's look at this example. The integrate dy dx is equals to 7. So with that, we see that y is equals to 7x plus c. That's how we get our solution. Let's move on to the third rule. The third rule is integrating constant multiples. So we have k times f of x. Now, in this case, we are saying that the k is an element of real numbers, but not equal to 0. So let's bear that in mind. So when you have such a scenario, we can factor out the k and integrate the x terms as we have it here. So the integral of k f of x dx is equal to k times the integral of f of x dx. Now let's look at an example. Integrate the following. F of x is equal to 6x squared. B, f of x is equal to 7 times square root of x. Now, with the a, we are saying that we can take out the 6 out of the integration and we integrate x squared by adding 1 to the power, dividing by the new power, so that we have 6 times x to the power 2 plus 1 divided by 2 plus 1 plus c is equal to 6 times x cubed over 3 plus c. Simplifying that, 3 into 6, we get 2. So that is 2x cubed plus c. Moving on to the b. For b, we do the same thing. We take out the 7. But remember, the square root of x, according to the laws of indices, is equivalent to x to the power 1 over 2. And dealing with that and integrating that, we add 1 to the half, so that we have 7 times x to the power half plus 1 divided by half plus 1 plus c is equals to 7 times x to the power 3 over 2 divided by 3 over 2 plus c. Now simplifying that, inverting that, we would have 7 times 2 over 3 times x to the power 3 over 2 plus c. Simplifying that, we would get 14 over 3 times the square root of x cubed plus c. That's an amazing question and example. Now let's get on to the last rule for the day. This is just the introduction to integration. We will cover other rules in our future videos, so make sure to share, like, and subscribe so that you don't miss out. So the rule for integrating sums and differences of functions. In this rule, we are saying if f of x and g of x are functions, then the integral of f of x plus or minus g of x with respect to x is equal to separated integral of f of x dx plus or minus the integral of g of x dx. That's how it goes. Now let's look at an example. Example 4. Integrate a, b, and c. So for a, we are going to separate each term. So we have x cubed plus 7 x to the power 1 over 3 dx minus the integral of 1 dx. We have separated this, and then integrating individually, we are going to get x to the power 4 over 4 plus 7 times x to the power 4 over 3 divided by 4 over 3 minus x plus 1. Remember how we integrate the constant. So 1 becomes x, and we add 1 and divide by the new power for the other terms. Now, of course, we cannot leave our answers unsimplified. So taking note, 7 over 4 over 3 is the same as having 7 times 3 over 4. which is 21 over 4. Now, substituting that back into what we had, we are going to have our final answer as that. So, I hope it's clear. If it's not, write in the comment section so that I attend to it. Now, looking at example B. Right, so with example B, because we haven't covered how to deal with the multiplications yet, it is wise for us to expand the brackets first, and afterwards we integrate using the sums and differences of functions. So in this case, if we expand the bracket, we are going to have 6x cubed plus 3x squared dx, that giving us that, and we separate the integrations, in separating the terms, we would get integral of 6x cubed dx plus integral of 3x squared dx. That would give us 6 over 4x to the power 4 plus 3 over 3 x cubed plus c. Now, simplifying that, we would get 3 over 2 x to the power 4 plus x cubed plus c. So that is how we would get to our solution. So now, we still use the same constant of integration, because remember, no matter how many terms we integrate separately, the constant of integration remains the same. It's just one. We don't have 3 of them or 2 of them. It's just one, right? So we move on to B. We've covered B, so we're moving on to the C. So moving on to C, we are going to multiply, expand the brackets once again, but remember from the laws of indices, if we have 1 over x, that's equivalent to having x to the power minus 1. Now, if we consider that and we expand our bracket, we are going to have 3x to the power 2 minus 1 plus x to the power half minus 1 dx. And remember, we have over 3, so from the rules of multiplying with the constant multiples, we can take out the 1 over 3 outside the integral function and deal with what's inside, so that we have 1 over 3 times the integral of 3x dx plus the integral of x to the power minus half dx. Now, with that, we add 1, we divide by the new power, so what we would have is 1 over 3 outside the brackets, and inside we'd have 3 over 2 x squared plus x to the power half divided by half plus c. And that would give us 1 over 3 times 3 over 2 x squared plus 1 over 3 times 2 over 1 times x to the power half plus c. Now, simplifying that, we have 1 half squared plus 2 over 3 x to the power half plus c. Now, we still have the same constant of integration. If you have made it thus far, congratulations. Your feedback is always welcome here. So make sure to share your experience in our sessions, your preferred numerical future topics, your questions, concerns, and suggestions. And if you haven't already done so, make sure to like, share, and subscribe. Thank you so much for watching Numbers Simplified. God